Welcome to Astronomy Daily, your go-to podcast for the latest and greatest in space and astronomy news. I'm Anna.
And I'm Avery. We've got a great lineup for you today, covering everything from the primordial Earth to mysterious dark matter, and even how to spot the Andromeda Galaxy.
That's right. It's going to be an action-packed episode. Let's dive straight into our first story, which is absolutely fascinating. Avery, tell us about this discovery that suggests we've found a piece of Earth that's older than the moon.
You got it, Anna. This is a game changer. Researchers have identified what may be the first physical traces of primordial Earth, the early version of our planet that existed before a massive collision reshaped it into the world we know it today.
Wow. So before the giant impact, essentially?
Exactly. A team led by MIT scientists with collaborators from China, Switzerland, and the US uncovered a rare chemical signature in ancient rocks dating back over 4.5 billion years. This study, published in Nature Geoscience, really challenges the idea that Earth's turbulent beginnings completely erased its original composition.
So fragments of the planet's first materials might still exist deep within the mantle? That's incredible.
It really is. Current models suggest Earth formed from a disk of gas and dust, with particles coalescing into meteorites and then young planets. Then about 100 million years after its formation, a giant Mars-sized object collided with our world. This giant impact not only created the moon, but also melted and mixed much of the planet's interior, resetting its chemistry. Most scientists thought the original building blocks were lost forever, but this new study says otherwise. The scientists analyzed ancient volcanic rocks from Canada and Greenland, which are known to contain some of Earth's oldest preserved materials. They focused on a specific isotope of neodymium, an element that's been used as a tracer for early Earth processes. What they found was a distinct neodymium signature that aligns with predictions for Earth's original building blocks rather than the thoroughly mixed mantle material that was thought to exist after the moon-forming impact. This suggests that some parts of the mantle were somehow shielded from the intense mixing that occurred during that cataclysmic event, preserving a chemical fossil of the very early Earth. It's like finding a needle in a cosmic haystack, giving us a direct window into a time we thought was completely lost.
That's truly astounding. So if these fragments of primordial Earth are still present, what does that imply about the early processes of planet formation and the scale of the moon-forming impact? Does this challenge our understanding of how thoroughly the Earth was homogenized after that event?
It certainly does. The prevailing theory was that the impact was so energetic it melted and mixed the entire planet, effectively resetting its chemical clock. This new evidence suggests that while the impact was monumental, certain deep pockets of the mantle might have remained relatively untouched. This could mean the mixing wasn't as complete as we thought, or that there were regions deep within the Earth that were resilient to such large-scale homogenization. It opens up new avenues for research into the Earth's geological history and might require us to refine our models of planetary accretion and differentiation. It also raises questions about whether similar primordial fragments could exist on other planets that experience large impacts.
Fascinating. Shifting gears slightly, let's talk about dark matter. This week, new research has shed light on how dark matter might be interacting with normal matter, or rather, not interacting in the way we traditionally thought. Avery, what's the latest on this elusive component of our universe?
Indeed, dark matter remains one of the universe's most profound mysteries. For decades, the prevailing theory has been that dark matter interacts with normal matter only through gravity. However, new theoretical work is exploring the possibility of a dark force that could mediate interactions within dark matter itself, and perhaps even with regular matter in subtle ways we haven't yet detected. This wouldn't be a direct collision or a strong force, but a very weak interaction, almost like a whisper across the cosmic void. It's a fascinating concept that could help explain some of the anomalies observed in galaxy rotation curves and galactic cluster dynamics that gravity alone struggles to account for.
A dark force? That's a captivating idea. So we're talking about something beyond gravitational interaction. How would such a force manifest? And what are the theoretical implications for detecting dark matter if it interacts in this novel way?
Well, if a dark force exists, it would likely manifest as extremely subtle interactions. We're talking about interactions so weak they wouldn't cause particles to visibly collide or strongly bind, but rather exert a gentle push or pull. Theoretically, this could create tiny perturbations in the distribution of dark matter that are distinct from what purely gravitational interactions would predict. Detecting it would be incredibly challenging, requiring highly sensitive detectors that could register these minute influences. It might involve looking for faint signals in experiments designed to detect weakly interacting massive particles, or WIMPs, which are a leading candidate for dark matter. Or it could even impact the dynamics of very diffuse dark matter halos around galaxies in ways we're just beginning to model. It's a frontier of physics, pushing the boundaries of what we understand about the fundamental forces of the universe.
That's truly mind-bending. The idea of forces beyond gravity shaping the cosmos is a testament to how much more there is to learn. From the unseen forces of dark matter, let's now turn our gaze to something a little more tangible, yet still incredibly vast. For our next story, we're going to talk about our galactic neighbor, the Andromeda Galaxy. Avery, for those of us who want to catch a glimpse of this cosmic marvel, what do we need to know?
Absolutely, Anna. The Andromeda Galaxy, also known as Messier 31, is our closest major galactic neighbor and truly a sight to behold. It's located about 2.5 million light-years away, making it the most distant object visible to the naked eye under dark skies. To spot it, you'll want to find a location away from city lights. Look for the constellation Andromeda. A good starting point is to locate the Great Square of Pegasus, and from one of its corners, you can star hop your way to Andromeda. Once you're in the general area, it will appear as a faint, fuzzy patch of light, almost like a smudged star. With binoculars or a small telescope, you can begin to resolve its elliptical shape and perhaps even hint at its spiral arms. What makes Andromeda so significant, beyond its stunning visual appeal, is that it's on a collision course with our own Milky Way galaxy. In about 4.5 billion years, these two colossal galaxies will merge, forming a new, even larger elliptical galaxy, which scientists have nicknamed Milkomeda. This provides an incredible natural laboratory for understanding galactic evolution and dynamics.
That's a fantastic guide, Avery. It's incredible to think we can see another galaxy with our naked eyes, and even more so to contemplate its eventual merger with our own. Speaking of things falling from the sky, but on a much, much closer scale, our next story takes us to Tennessee, where residents on Monday witnessed a spectacular green fireball meteor. What can you tell us about this luminous event?
That's right, Anna. This spectacular green fireball captivated skywatchers across Tennessee and surrounding states on Monday night. Reports flooded in of a brilliant, fast-moving object streaking across the night sky, characterized by its striking emerald hue. This color is a key indicator. It suggests a high concentration of magnesium and nickel in the meteoroid. As the meteoroid enters Earth's atmosphere at high speed, the intense friction heats it up, causing these elements to ionize and emit light at specific wavelengths. The green glow is particularly common with meteoroids containing these metals. These events are scientifically valuable because they provide opportunities to study the composition of extraterrestrial objects before they hit the ground or even vaporize entirely. Scientists use eyewitness accounts along with data from cameras and atmospheric sensors to triangulate the meteor's trajectory and estimate its original size and composition. It helps us understand the population of small space rocks orbiting the sun and how often they interact with Earth.
That's a truly captivating phenomenon. From distant galaxies and fiery atmospheric entries, let's pivot to the future of space travel and exploration. Our final story for today is about an exciting development: foldable solar sails for aerobraking and atmospheric re-entry. This sounds like something straight out of science fiction. What's the breakthrough here?
It really is. This is an ingenious concept that addresses a major challenge in space travel, efficiently slowing down spacecraft without massive amounts of propellant. Traditional aerobraking uses a spacecraft's heat shield to create drag in a planet's atmosphere, but it's often a single-use, high-stress event.
Foldable solar sails in this context aren't just for propulsion via solar radiation pressure. They're designed to be deployed and used as a large, lightweight drag surface for atmospheric entry and aerobraking. Imagine a spacecraft approaching Mars or Earth. Instead of firing thrusters or relying solely on a rigid heat shield, it unfurls these vast, thin membranes. These sails would increase the surface area exposed to the tenuous upper atmosphere, creating significant drag, allowing the spacecraft to slow down gradually and precisely. This dramatically reduces the need for heavy, costly propellant, freeing up space for scientific instruments or cargo. The foldable aspect is crucial. It means they can be packed compactly for launch and then expanded to enormous sizes in space. It's particularly promising for missions requiring gentle re-entry, precise orbital adjustments, or even deorbiting space debris. It's a game changer for sustainable and cost-effective space exploration.
And that brings us to the end of another captivating episode of Astronomy Daily. We've journeyed from the primordial Earth to the mysteries of dark matter, gazed upon the Andromeda Galaxy, witnessed a spectacular green fireball, and looked into the future of space travel with foldable solar sails. What an incredible array of topics, Avery.
And thank you for joining us on this stellar journey through the cosmos. We hope you enjoyed exploring these incredible scientific discoveries and advancements with us. Make sure to subscribe so you don't miss our next episode, where we'll continue to bring you the latest from the world of space and astronomy. Until then, keep looking up.
Astronomy.